chemicals. Today I'm going to talk about two very much kind of neglected things in construction. One is cosmetic repair. What is cosmetic repair and why it's important? And the second and the most important thing is the mold release agent. Why I said neglected is these are the two places where people don't give importance, and I'll just talk about why it's important and what are the things available in the market. So the first thing I'm going to take is cosmetic repair. So why we have to do a cosmetic repair, and this is related to precast. So the precast industry is characterized by the production of high quality concrete elements, and it has both the requirement, the quality demand more focuses on the technical side, as well as the appearance and finish of the concrete. Nevertheless, the surface defects and broken edges are unavoidable in the production process. So while we are producing any concrete element, the surface defects happen and it's unavoidable. So that is one reason why we need a cosmetic repair, so that we have an fair-faced, even concrete. The repair of defects require repair mortars. So the small defect requires a mortar, and it should be quick, it should be durable, and it should be there for life. So this is the main reason why cosmetic repairs are in place. There is a standard for it. BS EN 1504 is a standard for cosmetic repair and its mortar. There are two types of repair mortars as per BS EN 1504. One is structural repair and the second one is non-structural repair. Today, as it is cosmetic repair, we are going to talk about the non-structural repair over here. There are two classes in BS EN 1504 for non-structural repair, R1 and R2. The other two classes, R3 and R4, are for structural repairs. So these are the standard requirements as per BS EN 1504. The standard, it says the compressive strength should be greater than equal to 15 MPa, and is as per R2, and R1 it's 10 MPa. Chloride content in both is less than 0.05%. The bonding adhesive bond is the requirement is greater than 0.8 MPa. The shrinkage and expansion in R2 it's greater than 0.8 MPa. Thermal capability, freeze and throw, it's in the colder weathers in the colder countries, but as per R2 it's greater than 0.8 MPa, greater than or equal to. And for R1 it has to be visually inspected upon 50 cycles for defects. Thermal compatibility and thunder shower, the adhesion should be more than 0.8 MPS, greater than or equal to, and visual inspection after 30 cycles has to be done. Thermal capability and drying cycle, this is the sun, and it should be again 0.8 MPa, and visually after 30 cycles it has to be in R1 it has to be checked. Capillary absorption should be less than 0.5 kg per meter square per hour. In R1 it's not required, in R2 it's required. So especially to the designers, when they are designing a repair or designing a structure or giving approvals for small repair jobs, please refer to BS EN 1504. It will help you to suggest a product, and a majority of people here refer to this standard and suggest a product according to that. So the advantages of cosmetic repairs. So it's easy to mix and apply. It comes in a powder form. You just need to add water. It's pre-packed, so no labor-oriented mixing is required. It's just water to be mixed in a right proportion. Excellent adhesion to the concrete. It will not come out very easily. Smooth, easy production, the product finish is very good. It has very low permeability, so the water will not go inside, and thus will help in freeze and throw and again carbonation. So if the water will not go inside, the carbonation will have a benefit that the carbonation process will not happen. Reduces ingressment of waterborne salts such as chlorides and atmospheric attack. As a fairing coat, to cover and make good irregular finish of concrete substrates. So what this says is this coat, fairing coat also is available. With that you can finish the irregularities of the concrete, and there are small micro bubbles and pinholes on the substrate, so that all can be covered up, and a single color to the concrete or a concrete kind of finish is better, and irregular, because we use natural materials in concrete, so there are tendency of the colors to be varied from one segment to other segment, or one precast element to other. So if you use a fairing coat which can fill up small micro bubbles and give a single color fair faced concrete, as a skim coat prior to application of protective coating and painting systems. So this also helps wherever you are applying or going to apply a protective coat or a paint. This will help for the adhesion to the concrete. It will enhance the bond, as well as the pinholes and the finish will be better. The pinholes will not be there. So that is the main use of cosmetic repair. Okay, this was about the cosmetic repairs, and the next topic I'm going to take is mold release agent. I'll surely be taking questions after the session, so if you have anything, you can surely write it in the chat box. Mold release agent, the main purpose, what is the purpose of mold release agent? This is a regular question, and the main thing is when a concrete sets and hardens, the hardened concrete surface sticks to the formwork and makes it difficult to debond. This affects the life of the shuttering material as well as the concrete. At time when extra force is used to demold, it damages the concrete. I think everyone who is here have seen it once happening in their life at some site or somewhere. But it is there, and this problem is quite big in the industry. Sometimes demolding could be a cement plastered surface, and which in case the demolding or stripping of concrete member becomes all the more difficult. So it's so this is the reason why we need a good demolding agent. So there are 6 types of demolding oil available in the market. Nevertheless, we sell around 5 types as an industry. So the first type is neat oil. I don't think anyone in the industry sells this. It's generally mineral oil based, and it's just a neat oil. It can be burnt oil or reused oil, repurposed oil, which has been used in by regular contractor. It has its minus point, a lot of minus point. So it's not recommended to use in a high quality finished concrete, but still people use it. But there are minus points of this product, which I will be showing it to you in the next slides. The second type is oil-based with additives. So oil-based with additives has wettening agents to minimize blowholes in concrete, and they are good for penetration and and to resist chemical climate conditions. So this can be used while it's raining, or the surfaces are wet, or it's been the concrete has been the plates are been washed regularly. So these are the oil-based additives which can be used for getting a good fair concrete. The third one is emulsified mold release agent. There is a minus point in this emulsified system is if there is rain, it cannot be used because it's water based and it will wash away. The release agent will wash away. But other than that, this gives minimalistic pinholes or blowholes, and it's a general purpose release agent. except that they are not very suitable on steel formworks. Uh, the fourth one is wax base or other surface coatings. Basically, the wax base and other surface coatings are film forming. It is not a strictly release agent, but a sealer which prevents the release agent being absorbed into the form face. They are particularly used where it is necessary to avoid uneven porosity with consequent color variation in the concrete surface to give increased usage of foam work. So this will increase your usability of foam work very high. The fifth one is chemically active release agents. There are small quantity of chemical suspended in a low viscosity oil distillation, and the chemical reacts with cement to produce a form of soap at the interface. Recommended for all high quality formwork, especially my one shuttering and that kind of high quality formwork. They use a chemically active mold release agent. They should be applied lightly by spray to avoid retardation. Increased cost in these things and covers compared to oil-based materials. They generally have very good weathering properties, so they will not come out very easily, and they are technically very sound mold release agent. I'm going to talk a little bit more about the special release agents in my next slide because they include chemical system with vegetable oil based mold release agent. They are the latest technology right now, which gives a very high quality finish at a good price compared to other mold release agent. So here a good release agent should have these properties: provide and clean, easy release or strike without damaging either the concrete or the formwork. That's the most important. So when you dismantle the formwork support, the plate should come out very easily, or the ply should come out very easily. Contributes to the production of a blemish-free concrete surface. So the surface should not have any defect or blemishes which are caused by oil or contamination on the substrate. Have no adverse effect on concrete or concrete substrate. It should not have any adverse effect on the concrete. Aside in obtaining maximum reuse of formwork. So the repeatability of the formwork should be best, and it should be more optimal as supplied ready to use for form to constrain without side mixing. So there should not be any side mixing there. There are also emulsified shuttering oil or demolding agents where it comes in a concentrate and you have to dilute it with 5 part or 6 part of water. They are more in emulsified form. The inability, it has to be inhabitant adhesion, so it should not adhere, penetrate in the concrete and have any side effect. During application, be inoffensive to operators and regards to odor, skin. So it should not basically damage the people who are using it, or it should not have any harm effect. Be suitable for use in anticipated weather conditions. So for rain and that kind of weather condition, it should be available. The next I was going to talk about, the sixth one, is the benefits of vegetable oil based mold release agent. The basic advantage compared to any other oil based or chemical based mold release agent is it's vegetable oil based, it's biodegradable, non-toxic, it's environmentally friendly product, can be used with all types of formwork. It's non-staining. There is no stain remained on the concrete. It's safe to use, can be used in confined spaces like tunnels, because it does not have any fumes coming out of it. So for confined space, it's a very good release agent. Minimal cleaning of shuttering oil is being used. The release is very good. Ensures good fair-faced concrete substrate. It's economical compared to any other chemical-based release agent. It's economical, can be used for steam curing. So these are the this is basic advantage of the vegetable oil-based mold release agent. So how to apply, the correct method to apply the mold release agent is mold release agent should be applied on a clean formwork. There should not be any residue of earlier use, and it should be clean, very nicely clean. The product should be applied thinly. It should not be applied like a paint. It should be applied very thin and evenly as possible to optimize performance. Application by fine mist spray shall provide the best and the most economical performance. Any excess material should be mopped away. It should be taken out, and care should be taken not to over apply. So it should not be excessively applied. It should be applied just the right amount at the right place. So these are these are problems arising due to mold release agent. So the first picture you see here is the stain of concrete, and this happens because over applied mold release agent or a burnt oil is being used over here. And what you see here is this stain will be there for a very, very long time. And the second thing is the plaster you need to hack more, and it again hampers the strength of the concrete, and the adhesion of plaster will not happen over here, or any other coating or material you apply will not happen here. Blowholes in concrete, these are micro air bubbles in concrete. This happens because of not using the right release agent. And creasing in concrete, again one big reason. If it's over applied, the mold release agent is more applied, the creasing happens. So these are the problems, and we have a solution as an industry. I would like anyone, if you have any questions, please write to us. Fair-faced concrete substrate, these are some photographs of fair-faced concrete where you don't see any pinholes or air bubbles entrapped over here. So I thank you very much for giving us this opportunity, and hope everyone has taken something out of it. And if you have any questions, I am ready. I can answer you the same. Thank you.
Thank you very much, Parth. That was an interesting session. I would urge our viewers to please put your questions into the chat box, and we will take up the questions together at the end of the next session. So with that, I will actually hand over the baton to our second speaker for the day, Mr. Somen Maiti, and he will be talking to us a little bit about special admixtures for precast systems. So over to you, Somen, sir.
Am I visible now? Yes, I feel I'm visible now.
Yes, we can see you. You can share your screen also for the presentation of this.
Yes.
Perfect. Thank you.
Everything is clear now?
Yes, it's clear. We can see the presentation. Please go ahead, sir. Thanks.
Okay. Let me introduce myself. I am Somen Maiti. My educational means I am associated with this construction chemical fields approximately 26 years, and educationally I am postgraduate in chemistry. So presently I am associated with Fairmate, and today's topics discussion is that the admixtures for the precast industry. See, first we have to go that why precast is so popular in India right now, or not only in India, globally. Globally, precast is very much popular. Why? There are several reasons. Compared to the cast in situ concrete, the precast industry is much more popular. The number one reason, rapid industrialization and urbanization in emerging economies for the development of high quality infrastructures. So for high quality infrastructures, precast concrete is the one of the essential part nowadays. And also it indicates its precast construction, what will happens, because it speed up the process of construction. So speed up the, see, everybody nowadays, what's the reason that everybody wants to keep the production, the process as simple as possible and as fast as possible. So for that reason, precast is the most important sectors, and that is the reason. Another point is precast is manufactured in controlled casting environment. So as it is happening at the casting yards, so it is very easy to control the mix and placement and curing instead of in cast in situ condition, in cast in concrete. So, and also quality can be controlled and monitored much more easily. And on site, precast can be installed. So if we are casting the casting yard, and from there we can directly bring it at site and install. So there is no waiting period, no gain strength, because as it is already gained strength from the casting yards, so it need not require to wait for the extra time. And also one more thing, the repeatability. Repeatability is because it is casted in molds, so it can get repeated structures. We can multiple repeated structures we can generate. And so for that reason, it is easy to make many copies of the same precast product by maximizing repetitions. So that will be much easier, and it is very difficult to make this type of structures in the cast in situ concrete. Now, what I told, that cast in situ concrete versus precast concrete, what is the advantages? What advantages is it? What? That it is an accelerated curing by heating. Accelerated curing is possible in different methods, maybe heating the precast parts or various methods that will come later. But what I do, the accelerated curing is possible at precast, and process, because of tightly control the process from material to consolidation to curing, it is extremely durable concrete is possible. So that is the benefit of the precast industry compared to the any cast in situ concrete. So major benefit, whatever, that is, it can be controlled at site, it can be casted at site, and it is quality control can be done much better way, and also time consuming will be less. So that's the advantages. Now, whenever we're making the precast, as a construction chemicals manufacturers, what are the things required by them? Because construction chemicals manufacturer are not casting the precast. They are supplying the materials which are involved for making the precast. So for that purpose, what's the requirement of the precast? The low water cement ratio. Because this is required, why the reason is that it nowadays, say before 20 years back, there was a 35 concrete can be considered as a good strength. At present scenario, that is come to around 60 grade, which is average used. Maybe some places it is gone to 100, M100, M20, 120 also. So gradually it is seen that that strength of the concretes or precast is being increased, and whenever we need to increase the strength of the concrete, one of the basic parameters should be the low water cement ratio, because without this it is not possible for making the high strength precast. Medium workability. Another thing is medium workability, because it need not require to high workability in case of precast. It is not a ready mix concrete and it is transferred from one site to another site. So it is a medium. So it is because it is casting yield. So it is medium workability is more than enough. Very high water reducing admixtures. It is high water reducing. If it is very high water reducing admixtures, then only low water cement ratio is possible. And need for high early strength for high demolding. See, that is the again challenge for the construction chemicals manufacturers, that it should be that high strength, because high strength and high early strength. So strength should be why, if it's a high early strength, what happens, that can be demolded easily. So demolding is really fast. So same mold can be used 2 times, 3 times in a day. So that is the questions. So suppose, for example, normal precast without high early strength possible, or without steam curing if it is there, so that may be required 24 hours for demolding. But in that case, special, if we arrange to keep the special type of things, then it may be required within 8 hours, 6 to 8 hours we can demold it, and again we can cast the same mold. So same mold can be used 2-3 times in a day. So that will be productive, increase the productivity. And compatibility with cement replacement. So only cement is the not, there are another cementitious materials are there except cement. So that should be the compatible with the mixed design, and compatible with the 100% crushed sand or manufactured sand. So these are the minimum things are required for the precast concrete. Now I am coming to the point, what is actually required for the admixtures in precast concrete. See, if I come to the admixtures point of view, admixture is not a new thing for anybody. Frankly speaking, the admixtures uses has started from the Roman Empire, where they are used such as some milk, blood, as well as some organic materials like molasses, eggs, rice paste, that are being used that time during the Roman Empire, that used for increase the workability of cementitious mixtures that time. And if we see the history of admixtures, first in the year 1873, the first time admixtures comes in Germany, that is in calcium chloride based. Calcium chloride is basically an accelerator, but calcium chloride based. Then coming one by one, that air entraining agent, retarders, as well as accelerators, water reducer, etc., etc. So first, structurally, admixtures was enrolled in the year 1962 by ASTM C494, and that time only 5 type admixtures was given, that A, B, C, D, and E. That 5 types admixture was there that time. The 5 types means that water reducer, type A is the water reducer, type B is the retarding admixtures, type C is accelerating admixtures, type D is the water reducing admixtures and retarder, and type E is the water reducing and accelerating admixtures. These 5 admixtures are started in the first ASTM C494 in the year 1962. Afterwards, it was started that even if we see the ACI Committee 212 American Concrete Institute publications 2120, that also did not mention that high range water reducing admixtures, what we are presently is being used. So high range water reducer practically started after especially I can tell more specifically in the year 90. This time in the 1990 approximately that time, it has started the high strength high range water reducer. One survey I found, one survey that in 92 in USA, they found that only 71% of the concrete they are produced by the admixtures, but only 2% contains that high range water reducing admixtures. So that means it has started from the 1982 somewhat, but major boost up has happened in the year 1990, where there are a dramatic change, and major focus for high strength admixtures is for precast industries only. Major focus. So what's the function? With advanced concrete technology and suitable admixtures application, adequate workability, rapid installation, and fast strength development of the concrete can be ensured. And majority before high range water reducing admixtures, mainly the admixture was based on lignosulfonate based, maybe sulfonated naphthalene formaldehyde, sulfonated melamine formaldehyde based, sulfonated naphthalene formaldehyde based. So these are the product earlier being used, but at the adventures of when the polycarboxylate based admixture has started, that time before polycarboxylate admixtures, they have some limitations of that particular type of admixtures, what I told, like lignosulfonate, SNF and SMF based admixtures. But that all the problems are sorted out by the incorporation of polycarboxylate based admixtures. So polycarboxylate based admixtures, when it's come, so everybody is thinking the admixtures, okay, one thing is attained as per the requirement of the precast, that high range water reducer, it can possible for high water reduction in the concrete, and that can attain the good strength as well as the durable concrete. So one point is there. So what will come for the next point? Superposition. Next point means how it is possible for accelerated hardenings. So now the question is coming that accelerated hardenings. So the first point is that high strength. Now it is coming accelerated hardening means high early strength. When I'm coming for the high early strength, so conventional accelerator is not suitable for the precast industry. So conventional accelerator means what I'm talking, you can see that average conventional accelerator average, it is basically you can consider four types of admixtures, four types of accelerators. That is inorganic salt based and inorganic salts like chloride, fluoride, thiocyanates, nitrites, nitrates, it's this like this. Another organic compounds based, which is basically trithanolamine, calcium formate, oxalic acid, lactic acid like this. And another that quick setting admixtures, which is basically aluminate, carbonate, silicate, and miscellaneous solid admixtures, different types. But ultimately, whenever we are accelerator we are giving, we have to think about it. It can retain the proper workability of the concrete. See, whenever putting accelerator, it should not set within 10 minutes, 15 minutes. Then that it is not proper workable. So you have to give the time for the proper casting of the concrete, casting inside the mold. So it must have. So challenges are what? It must have high range water reducer, and then it's have a accelerator, but it's such a accelerator means it is one type of accelerator, but accelerator not like the conventional accelerator, which can accelerate maybe 10-15 minutes, half an hours, which we are talking about the shotcreting. It should not be like shotcreting type. So these are the challenges. So now because of that, the new technology, I am talking about the new technology which is coming for the admixtures point of view. See, instead of incorporating the conventional accelerator, how the construction industries has gone to the high early strength for making the high early strength concrete. So for that, the first term is coming, the seeding technology. Seeding technology is the one of the revolution in this type of precast industries. So it's like seeds. Say seeding technology, why it is saying, say it is from the seeds, the plants have started like that. It is working in a similar way. It is basically based on nanotechnologies, that is synthetically produced nanoparticles of calcium silicate hydrates, nanoparticles, that is calcium silicate hydrates, as well as the nanosilicate, which is specially which is common. It is incorporated during the making the concretes, and this product improve high early strength. So few products, this is basically aqueous suspension of nanosilica as well as the nano calcium silicate hydrate, because we know that how the compressive strength of cement generates. Cement, if we know that whenever the cement reacts with water, that time it is making the calcium silicate hydrate, and calcium silicate hydrate is the main part for making the strength of the cement as well as the concrete. So if we anyway increase the percentage of calcium silicate hydrate in the system, so automatically as the calcium silicate hydrate is the main part for giving the compressive strength, so if we incorporate the calcium silicate hydrate by other way, by external way or whatever, maybe there are some materials which can produce calcium silicate hydrates once again, so that can increase the compressive strength remarkably. So it is a basically aqueous suspension of nanosilica as well calcium silicate hydrate, and these are the seeds which is practically impregnated in the concrete, and gradually it making a millions of calcium silicate hydrate particles, and because of that calcium silicate hydrate particles and fast ratio, it is giving very high strength of the high strength concrete. So if this process high strength, if you see the process, if you see the pictures, left side is already given that without incorporating the seeding, left side what are the things happens, and right side if you see the pictures, it is already formed so much calcium silicate hydrates, and strength with strength enhancement, if you see it can 25, if you see that 25 MPa without the normal thing, normal admixtures, whether by incorporating the calcium silicate is a 40 MPa, see the increase happens for high early strength, and because of that we can even use we can demold the concrete within 8 hours. Then see the strength enhancement happens in case of using the seeding technology, and in that case main focus is 1 day strength. See, if we get a 28-day strength, it will not that much effect. It will be increase, not that much. It will definitely increase some extent, but not that much like 1 day and 7 days, or 3 days, 1 day, 3 days and 7 days. So these are the, if you see the graphical representations from there also, you can understand that what is the percentage increase happen in case of 1 day and 7 days. And if you see the 28 days strength, that has also increased, but not that the similar way like 1 day and 7 days. Now that I told this technology, but another new technology has come from the admixture itself, that PCE manufacturers, that you make the admixtures in such a way that itself increase the strength 20 to 25 to 30% compared to the normal PC admixtures. So admixtures, what the structures of the admixture is such that it itself increases the strength. So how it is possible? It is because of it is the basically possible by the PC manufacturers, where generally what happened, they can reduce the branch chain polymerization. See, the PC is a vast subject. Practically polycarboxylate is a very vast subject, and various structures, various polymerization possible, permutation combination possible. So in that case, the peoples are trying that how it can be possible to make the such a admixtures. We usually invert PC, which can increase the strength as usual without adding extra ingredients, or without adding extra strength generating materials. So in that case, there are materials that are available, which practically the main chain polymerization, their branch chain polymerization to convert it the linear chain polymerization. So branch chain, what happens whenever the PC is in branch chain, that time the ionic functional group concentration of ionic functional group is the more. But whenever we're making a linear chain, that time lower concentration of ionic functional groups, and that is the aqueous phase, and that practically accelerates the setting time of cement. So that's the way it is also possible. So frankly, so in a brief, I can tell you, I have just covered only the admixtures, which is the latest possible admixtures. I have not considered the common admixtures. Basically, three type of admixtures I covered. Was the high range water reducing admixtures for the precast industries, and the another admixtures which is basically seeding technology, that is also admixtures, but it has to be added separately with the admixtures of high water reducing admixtures. And third admixtures, which is the accelerating admixtures. We admixtures, the PC chain is such that by adding that admixtures itself, it can increase the strength of the concrete. So increase average as I go to the next slide, that 1 day strength, it is found 25 to 30% compared to the normal PC admixtures. That much capable of this accelerating admixtures. So in a short, briefly, what happens? The cost efficient latest concrete production active following benefits. What happens? The cost efficient concrete mix design, superplacid admixtures. What actually it happens, that it contributes significantly whenever we use the superplasticizers. That time what happens, because of superplasticizers, it can reduce the strength, reduce the water content from the mix. And as you mix the water content, that time we have a possibility to make a particular design of concrete. We have a possibility to reduce the cement content. So ultimately what happens, by using the superplasticizers, cement percentage is reduced. So that in that case, it happens that cost is becoming cheaper. Production of high strength and high durable concrete. High strength, as I told, that because of high water reducing admixtures, it can reduce a huge percentage of water from the mixture to get the similar workability, and because of the less water, so automatically concrete strength will be high, and as well as durable also, because this ultimately all water is not using the hydration of cement. Some water is already evaporated, so it is making more porosity. So that porosity will be reduced as due to presence of minimum water. And self-compacting concrete are also possible with the use of, as I mentioned it, high range water reducing admixtures, rapid installations. So a self-compacting concrete, why it is required? So it is no need required of vibration work, and reduction or elimination of heat or steam curing. See, whenever we are using this type of admixtures like seeding technology, as I told, like admixture of high oil strength admixtures, in that case you need not require the steam curing. See, in absence of those admixtures, to get the demold first, it needs the steam curing or hot heat. So that need not required now. So if that is required, so steam means it needs electricity, it needs time, electricity. So electricity, that point of that is being discarded. So ultimately what happens, sustainable and environmental friendly production. So ultimately any construction, if we able to reduce the percentage of cement, so it is becoming environment friendly, because all you are aware that cement generated the pollution in the atmosphere through carbon dioxide and the other way. So it's a sustainable production, which way it is becoming. So cost efficient, as I told, cost efficient because it is it is minimizing the percentage of cement, it is minimizing, and because of low water cement is making a durable concrete, and it is a self-compacting in nature, it need not require to vibration, and so rapid installation and time savings because of reduction or elimination of heat and time savings, and it can reuse the mold several times, and sustainable environmental friendly production. So that is the main points I just wanted to focus today. Hope and all the persons are, I like to thank to, and hopefully this is the, I feel this is my last slide. Thank you. And I sincerely thanks to everybody to so much time to listening my discussion, whatever the my speech, so that at least if what I have told from my experience, from my different sites situations, so we understand these are the common requirement for the construction chemicals fraternity. Thank you.
Thank you very much, Mr. Mehti. Just 1 minute. Maybe we can just stop your screen share. Excellent. So I think it's time we go to a few of the question answer sessions. So let me just get my chat box up here. Um at least on my
Yes.
end, I'm not seeing any questions. Could you just please also check it in your chat box whether some questions have come to you?
Mm,
That was a couple of very interesting session, in which we think about how to actually make precast concrete segments look better. So, like with the mold release agent, that's one. In case there are damages, then you're using the cosmetic mortars, and of course with the new age admixtures that you can actually get both good finishes as well as good durability, strengths, and so on. Okay, so I'm just getting a question here. I think Soumya, this is for you. Um, by using admixture, the strength increases directly. This is from Mr. Ujwal Shukla from Kathmandu.
hmm.
That is the
What is the
question.
question?
So, by using the admixture, does the strength increase directly?
See, yes, see how it is increase the strength directly because the by using the admixture, see, I have already mentioned that it can increase the strength in two ways. First way is by using the high strength, high water reducing admixtures, that ultimately it is reducing the water from the concrete. So as long as you are using the less water in the concrete, so automatically strength will increase. That is number one. And number two, I have mentioned another type of admixtures, which itself has increasing the strength, and that is because of the chain, because of the particular chain of the polycarboxylate. So that particular chain, if we used, that can increase the strength.
So it goes both ways, means either with a hardening accelerator or and also by controlling the water cement ratio. So
Yes.
that's good. That's interesting. I think there is one question about costing and everything. I think those kind of questions can be taken offline, or you can write to us and we'll
Yes.
pass it on to the we can pass it on to the authors themselves.
Sure.
Uh,
Yes, we are ready to reply afterwards also through email.
Correct,
No
correct.
issue.
That because costing it's kind of tricky
Yes.
chapter, and we'll rather like to keep the focus technical out here. Uh, I think that does it from my end. Could you just please take a look in at your chat box as well,
I
whether if
am
there are any
also not
questions over
chat
there?
box. Just a minute. I'm just checking.
It will be at the bottom
Uh,
of your screen.
just a minute. Wait now. What's uh, no? I am also not getting any such questions. Is admixture? Is seeding admixtures available in India? There. Yes, it's various companies are making this one it is available in India.
Okay, that's good. There is one more question.
It is available. It is available in India. It is we have also having and other companies also having. It is available.
Technology is going ahead quite fast. This is another question here from
Yes.
Engineer DP Sengupta. He says heat curing has a few issues regarding long-term strength behavior and delayed ettringite formation. Seeding, so the seeding technology have any impact on those, like either more or less? And then, is there any dosage recommendations for these kind of admixtures as well?
Means I'm talking of what I understand that seeding technology admixtures is doses.
Yeah, one question is
Doses
the
of seeding technology admixtures.
and the other is the impact on the long-term strength behavior and delayed ettringite formation.
No, as per as I informed that seeding technology is practically incorporated of nanoparticles of calcium silicate hydrate in the phage. So it does not have any bad effect in the concrete itself. Rather, it can reduce the porosity of the concrete and increasing the strength. So practically, it is becoming much more durable. It is no questions of reducing the strength or long-term effect, the reduction of the strength.
Okay, so that means the long-term effects are not there. And what's the general
Yes.
dosage for these kind of materials?
Doses, it depends on different types of mixture. Generally, it doses started from even 2% to 3% average by weight of cement.
Excellent. I think there's another one question from Mr. Amit Magaji. Please suggest admixture for pile foundations for huge water is there. I'm not able to completely
See, I
understand.
feel it is not related to the precast.
Yeah, because it's directly for pile foundation. So I think it. I would say you'll have to work with a little bit with the mixed design to get that kind of stability to go into the pile pretty much.
No, basically, did they need any particular type of admixtures? The admixtures are available. It is a vast market.
Correct.
So various type of admixtures are available. So it needs to know the actual requirements. Then only you can suggest.
Absolutely. I think this is I just got another message from Mr. Sen Gupta. Dosage of the seeding admixture. I think that is what Mr. Somen said. It's about 2 to 3%, right?
2 to 3%.
Yeah, 2 to 3%. Excellent.
Yes.
Okay. Another question is this is from Mr. Ujjwal Shukla again. Can the efflorescence be reduced by using these kind of admixtures?
Surely fluorescence is reduced. See, fluorescence, why happens fluorescence? As the porosity of the concretes are there, so automatically through the pores, so many others like carbon dioxide is going inside the system, and that carbon dioxide reacts with the calcium hydroxide, which is the byproduct of the cement, and that calcium hydroxide converted to the calcium carbonate, and that is gradually coming on the top. So if that is the source of fluorescence, so now if that area is stopped, so see the making durable concrete, we can reduce the fluorescence, but you cannot stop totally, because concrete is not totally spotless, totally free, pore free is not possible. So in that case, it required to maybe coatings, different coating, that way it has to be changed. But yes, of course, compared to the normal conventional concrete, high range water reducer, if you use, automatically the percentage reduction huge of fluorescence.
That's excellent. Any questions with respect to the mold release agents or the cosmetic repairs that we saw earlier on? And we're talking a lot in the field of admixtures, but let's see if we can.
So far, I am also not getting any questions regarding this mold release agent as well as the cosmetic repair matters.
So excellent. So I think if there are no more questions, we can wrap up today's session. So big thank you to Parth. Big thank you to Mr. Somen. Thank you very much for sharing your knowledge today here with us. I know it's precast. It's a newer, kind of these new materials are, I would say, a good look or a good overview into the new technologies available today. And hopefully our viewers really found it useful, and as well can use a lot of these technologies in their upcoming projects. So with that, I would say thank you very much for attending today. It has been a nice session. Could have actually used a lot more or a bit more of interaction, but thank you very much for attending. Thanks for listening. We shall be getting back to you soon with the next with the announcement for the next webinar session as well. So from Sunny Surlakar, your host for the day, I would say thank you very much. Once again, thank you, Mr. Parth. Thank you, Mr. Somen.
Thank you, Sunny.
Thank you, and having a nice weekend.
You were a great host, and we enjoyed. Thank you very much.
Thank you very much. See you all pretty soon. Bye.